So hello and welcome to the continued coverage of the walkthrough series, and in this episode we are looking at the 9618 variant 4.2 of May June 2025 paper. So let's go ahead and jump right in. So for this particular question, rather for this particular session, we were given three text files: stack data, second stack hash data.txt, and these first two text files are the ones that we are going to be using in this video for question one. Then the other one, I think we'll use it for the next video for episode 2. So a program reads data from a text file and stores it in a stack. The stack is stored as a 1D array of up to 20 elements, and we are also told that the name of the stack is going to be called stack. The pointer top of stack stores the index of the last element stored in the stack. Then A says that we should actually just initialize declare and initialize these variables. So we want to have a list called stack with all the elements set to -1, and we're also going to have a variable called top of stack with a value of -1. Take note that this is a string, and that is why -1 here is in quotes. So that's what we need to take note of when we initialize our list, as it were. So let's go ahead and look at the code that I have going on here. So on lines 5 and 6, that's where we have the declaration and initialization, as it were. So we have a list called stack, and we want it to have elements of -1 in a string of -1, as it were. And we are simply multiplying it by 20 so that we have 20 elements of that in that list, as it were. Then the top of stack is just going to have a value of -1. Then of course you'd have to copy this code and paste it inside of your evidence document. Then moving on to part B, we are to create a function called push that takes a string parameter and attempts to store it on the stack. The function returns -1 if the stack is full. Then the function returns 1 if the parameter is successfully pushed onto the stack. So we are to write program code for the push function right here. So let's go ahead and look at the implementation that I have going on. So since the function takes a parameter, you'll see that on line 9 there we have this parameter called data. Then we are referring to this top of stack variable there. So that's why you're seeing we are making use of the global keyword, is it? So that the function knows we are referring to a global variable called top of stack. Then we are simply checking to see if we currently if top of stack is currently equal to -1, in which case we are simply going to return -1, is it? The reason why we are taking length of stack -1 is because length of stack is going to be a number. Let's say if currently we have nothing in the stack, right? The length of stack is going to be 0, right? So if you say 0 -1, then top of stack has a value of -1, then -1 will be equal to -1. In which case it simply means that we have nothing inside of the stack. That's why you see we have that -1 there. If you were to leave this -1, then you'd have issues. Then top of stack, so should we have space to push our stack, as it were, space to push an element into our stack. We would then push the element into the top of the stack. Then remember this notation on line 13, it's more or less the same as saying top of stack is equal to top of stack plus 1, is it? So we are just incrementing top of stack by 1. Then we are going to push the data that was passed in as an argument to the current position in our stack. Then we return 1 to show that the push was successful. Then of course you would copy this code and paste it inside of your evidence document. Then moving on to part C, we have another function called pop. Pop is the way through which you can remove an element from a stack, as it were. So we are to create this function which returns -1 if the stack is empty. Then you need to remember that for a stack you cannot pop or remove an element if there is nothing in the stack, as it were. So that's why we are returning -1. But if there is something in the stack, we need to return the topmost element in the stack, as it were. So let's look at the implementation going on here between lines 18 and 24. Then you see that again we're referring to the global variable top of stack on line 19. Then if the top of stack is currently pointing at -1, it means we have nothing inside of the stack, so we simply return -1 as a string. Otherwise we are going to take the item that is at the top of the stack and store it inside of this variable called item. Then we need to remember to update our top of stack variable because we just removed an element, so we decrement it by 1. and then we return the item on line 24. So of course you copy the code and paste it inside of the evidence document. Then part D, the text file stack-data.txt stores numbers and mathematical operators. Each number and operator are on a new line in the text file, right? So let me just open the file so that you can see what we have going on. So you see that we have a number, operator, and so forth and so on. So that's what they're just telling us right here. Then they are giving us the meanings of the operators that are inside of the file. Obviously, we know these from our programming as well as from our pseudocode, as it were. So we are to write program code for the function called read data that's going to do the following, that's going to satisfy the following requirements. So it takes a string file name as a parameter, opens the file and reads in each line of data. Then it uses the push function to insert each line of data onto the stack. Then it outputs stack full if any data cannot be stored on the stack because the stack is full. Remember, our stack has a maximum size of 20, so we cannot exceed 20 elements. Then it also uses exception handling when opening and reading from the text file. So let's go ahead and look at the implementation that I have going on here for read data. So the read data takes a parameter, that is the file name. So we have file name there as a parameter. Then since we are going to be using exception handling, we are going to make use of a try except block, is it? So we are going to open the file on line 29 in read mode. Then for each line in the file, we are going to push the result onto, we are going to take that line and call the push function, is it, and store it inside of result. Then if the result is equal to -1, then it simply means that we have nothing to push onto the stack. Then we break out of the loop, rather of the function, right? Otherwise, actually it's out of the loop, yes, because we are inside of a for loop here. So we break out of the loop because we cannot push anything. Otherwise, we are using exception handling here on lines 35 to 38 to handle a situation whereby we are not able to find the file or we have any other exception really. So you see that on line 35 we are calling the file not found class and just format printing the error there. Then on line 37 we are calling the exception class and creating an exception object. Then we can make use of that exception object here so that we have a description rather of what the problem is. Then of course you would copy the code and paste it inside of your evidence document. Then part E here, we have the values stored in the stack are used to perform mathematical operations. A total is initialized to the first value in the stack. The first value in the stack will always be a number, right? That's important to note. Even if you go to the file, you see that the first value that is on the first line is actually a number. That's there's 3 there. So yeah. Then we are told the next value will be mathematical operator. Basically, they're just saying that the values and the operators, they are alternating like in this graphic right here. Then we need to initialize the first value with the top of the stack. So we take the element that is at the very top. Then next we take the operator and the next value. Then we perform an operation. Then we continue doing that until we have a value, is it? So we are going to call the function calculate. Then it's going to take the values from the stack and calculate the final total. This one is worth 7 marks. So there's a bit of planning that you need to put into this one before you deliver the final solution. So here is the solution for calculate, rather the implementation for calculate. So we are taking the current value that is at the top of the stack and storing it inside of the total. Then next we are checking to see if the top of the stack is not equal to -1, meaning to say that if the top of the stack is not equal to -1, it means we now have nothing to work with. But if it is not equal to, then definitely we have something to work with. So the next thing that we're going to do is we're going to take the next element, pop the next element and store it inside of the operator variable. Then we are also going to take the next element, that is the third element this time around, because this is the third time calling pop, is it? So when you call pop for the third time, it means you are now taking the third element, as it were. So the third element is definitely a number, so we are going to store it inside of that variable called number. Then should the operator match any of these cases, so if the operator that we popped in the second instance or in the second call to pop was a plus, then we are simply going to add the total the number to the total residual. So remember the notation for here, you might actually do something like this. You might actually do something like total is equal to total plus num, right? That is the full form. And on line 48 there, I just used the shorthand notation, but the full form is actually total is equal to total plus num, is it? So I can just comment this out, then uncomment this line because that's what I want to use, the shorthand notation. So should the operator match any of these cases, then we are simply going to perform the relevant operation. Then let me just quickly point out that with Python, if you use a single /, you are going to get it's actually going to perform real number division, as it were, is it? So if let's say you were to divide 10 by 3, you'll actually get 3.3333, and you don't want that for this particular solution. So the way to handle that situation is to make use of the double /, which is basically the way you do integer division in Python. So that's important to note right there on line 55. Then after doing that, we simply, it's going to iterate until there's nothing in the stack. Then by then, when the stack is now empty, we would have a running total, as it were. So we'll just simply return the total from this calculate function. Part F says we should write a program code to extend the main program to take a file name as input from the user, call read data with the input file name, call calculate, then output the final total. So let's actually go ahead and look at the implementation going on here in the main program. So you see that we have the file name, a variable that's storing whatever the user types in. Then we are calling read data according to the second requirement. Then the third requirement requires us to call calculate. So we will call calculate and store the result inside of result. Then eventually we are going to output the final total. So we simply say final total is going to be the result, whatever is inside of result. Is it again, we are using format printing here because it's much more elegant than having to concatenate strings and numbers. Then item 2, test your program twice with the file names. So we are going to test the program with stack data.txt and second stake.txt, then take a screenshot of the output. So let me just open up my console here, cycle the command because I did it earlier on off screen when I was writing the solution. So I'm just going to hit enter. So the first file is called stack.txt, and wait, is it stack.txt or stack data.txt? Let's run the program one more time. I think it's stack data. I made a mistake. So yeah, you see that it's giving us a total of 131, is it? Then if we run the program for the second time around, we are calling second stake.txt, and you see that the final total is what is 320. Then of course you would take a screenshot of this output and paste it inside of your evidence document. So yeah, I think that's just about it for this video. Hopefully you learned something, and I'll see you in the next one.